Let's journey to the farthest, coldest reaches of our solar system, the deep freeze where sunlight is just a distant glimmer. Beyond the familiar planets lies a vast, frozen frontier, a realm where methane and nitrogen turn to ice, and the sun is barely more than a star. This isn't empty space. It's a cosmic attic, packed with icy relics from the birth of our solar system. The Kuiper Belt and the Oort cloud are our main destinations, zones teeming with comets, dwarf planets, and ancient debris. These objects are time capsules, preserving the solar system's original ingredients. By studying them, we unlock secrets about how Earth and the other planets formed. It's cosmic archaeology, digging into the past to understand our present. So, buckle up. We're heading into the coldest, most mysterious parts of our solar system. We'll explore the missions that dared to venture here, and the discoveries that changed everything. The frozen frontier isn't just a distant curiosity. It's a key chapter in our own story. Its secrets are just beginning to be revealed. This is where our solar system's story began, and where new chapters are still being written. Ready to explore the ultimate deep freeze. Let's go. First stop, the Kuiper Belt, a colossal ring of icy bodies beyond Neptune. Once just a theory, we now know it's packed with hundreds of thousands of objects, from tiny chunks to dwarf planets. Pluto is its most famous resident, but it's just one of many in this frozen family. Pluto's reclassification as a dwarf planet came from realizing it's part of this vast population. Kuiper Belt objects, or KBOs, come in all shapes and sizes, some round, some potato-shaped, some with moons of their own. Their colors and compositions vary, hinting at a rich diversity of ices and rocks. The Kuiper Belt is a graveyard of planetary leftovers, building blocks that never formed into full planets. Preserved in deep cold, these objects are nearly unchanged since the solar system's birth. By studying them, we peer back billions of years to the raw materials that built our world. It's a direct link to the primordial soup from which everything in our solar system emerged. The Kuiper Belt isn't just a distant ring, it's a living record of our origins. Each icy world is a page in the solar system's history book, and we're just beginning to read it. The more we discover, the more fascinating this frozen realm becomes. Let's keep digging. Beyond the Kuiper Belt lies the Oort cloud, the solar system's ultimate boundary. Unlike the flat Kuiper Belt, the Oort cloud is a vast spherical shell surrounding everything. It's so distant, its inner edge is thousands of times farther from the sun than Earth. The Oort cloud is home to long-period comets, icy visitors that take millennia to orbit the sun. We've never seen the Oort cloud directly, but the orbits of these comets reveal its presence. Comets are nudged from this cloud by passing stars, sending them on spectacular journeys toward the sun. The Oort cloud holds the most pristine material in the solar system, untouched for billions of years. These objects were likely flung out by giant planets in the solar system's chaotic youth. Studying them would be like opening a time capsule from the dawn of creation. The Oort cloud is our solar system's final frontier, a treasure chest of cosmic history waiting to be explored. One day, we may finally unlock its secrets. Why does all this ice matter? Because it's a frozen record of our solar system's past. Like Antarctic ice cores, these distant ices trap the original chemistry of the solar nebula. These icy bodies, planetesimals, are the building blocks that form planets and delivered water and organics to Earth. The water in our oceans and even in our bodies may have come from these ancient comets. By analyzing their composition, we test the story of our own origins. These worlds also contain complex organic molecules, the raw ingredients for life. Finding them suggests life's building blocks were widespread from the start. Every comet or icy world we study is a piece of cosmic archaeology, revealing how planets formed and life began. The ice is a library, preserving the first chapter of our story. That's why we send spacecraft across billions of kilometers, to read the secrets frozen in time. The payoff? Understanding where we come from. To unlock the frozen frontier's secrets, NASA launched New Horizons, the fastest spacecraft ever sent from Earth. Its mission, the first ever flyby of Pluto and its moons. After a 9-year, 5 billion kilometer journey, New Horizons arrived at Pluto in 2015. The probe had just hours to capture all the data it could as it sped past at over 50,000 kilometers per hour. The team pre-programmed every observation with precision. There was no second chance. Along the way, New Horizons used Jupiter's gravity as a slingshot, gaining speed for its epic journey. Most of the trip, the spacecraft hibernated, waking only for checkups and its final approach. As it neared Pluto, the fuzzy dot became a detailed world. Images trickled back to Earth, each sharper than the last, revealing features no one had ever seen. It was a moment of pure exploration, the culmination of decades of planning and patience. For the first time, humanity met Pluto up close. And what we found would change our understanding of the outer solar system forever. The age of exploration was far from over. New Horizons shattered our expectations of Pluto. Instead of a dead ice ball, we found a dynamic world with a vast, heart-shaped plain of nitrogen ice, Tombaugh Regio. This plain is geologically young, with few craters, and bordered by towering mountains of water ice as hard as rock. We saw glaciers, canyons, and possible ice volcanoes, evidence of ongoing geological activity. Pluto's thin nitrogen atmosphere was hazier and more complex than expected, with layers of blue haze encircling the planet. Even Pluto's largest moon, Charon, revealed massive canyons and hints of a once liquid interior. These discoveries proved that even in the deep freeze, worlds can be active and surprising. Pluto's landscape is bizarre, beautiful, and utterly unique. The flyby taught us not to underestimate the complexity of distant worlds. The outer solar system is alive with geological wonders, and Pluto is just the beginning. There's so much more to discover. After Pluto, New Horizons set its sights on a new target, Arrokoth, a tiny, ancient Kuiper Belt object. In 2019 it became the most distant world ever explored up close. Arrokoth looks like a flattened snowman, two lobes gently fused together, its smooth, reddish surface, and lack of craters reveal it's been undisturbed for billions of years. This shape tells us planets may have formed through gentle mergers, not violent collisions. Arrokoth is a pristine relic from the dawn of the solar system, a snapshot of planet building in action. It hasn't been heated or changed, preserving the conditions of the early solar system. Studying Arrokoth refines our theories of how planets like Earth came to be. It's like finding a fossilized dinosaur egg, untouched and full of secrets. The New Horizons flyby was a monumental achievement, giving us a direct look at our solar system's building blocks. Each new discovery brings us closer to understanding our origins. The Kuiper Belt is a treasure trove of planetary history, and we've only just begun to explore it. New Horizons opened the door, but the frozen frontier still holds countless mysteries. Scientists are already planning the next wave of missions, faster, smarter, and more ambitious. Future targets include other dwarf planets like Haumea and Makemake, each with their own unique features. A Pluto orbiter could watch glaciers flow and monitor ice volcanoes over years, revealing ongoing changes. The ultimate dream? A mission to the Oort cloud, sampling a pristine comet before it's altered by the sun. These missions will require new technology and bold ideas. Each step builds on the last, pushing us deeper into the unknown. The scientific rewards are immense, understanding planetary formation, the origins of water, and the ingredients for life. The frozen frontier is the next great challenge for exploration. With every mission we get closer to the edge, and to the answers we seek. The story of our solar system is far from finished. The best chapters are yet to come. Our journey to the solar system's frozen edge reveals a cosmos richer and more mysterious than we imagined. The Kuiper Belt and Oort cloud are not empty. They're archives of our solar system's history. Missions like New Horizons transform distant dots into vibrant, active worlds. Pluto and Arrokoth have given us new questions and a deeper sense of wonder. Exploration is how we read the frozen record of our origins. The future will demand patience, ingenuity, and new technology to reach even farther. We want to know if worlds like Pluto are common, how planets form, and how water and life's ingredients travel across space. These are the questions that drive us to explore. Each mission adds a new page to our cosmic story. The chapters on the Kuiper Belt and Oort cloud are still being written. With every discovery, we learn more about our place in the universe. The frozen frontier connects us to the very beginning, and that's a story worth telling. The year is 2180. Humanity stands at the threshold of a new era, one that was once only imagined in stories and dreams. For millennia, humanity gazed at the stars, dreaming of what lies beyond. Our ancestors wondered if we were alone, if other worlds circled distant suns, and if we could ever reach them. Probes and telescopes brought us images of distant galaxies, but pictures were never enough. The mysteries of the universe called to us, urging us to venture further. The human spirit yearned to go, to see, to touch. We longed to cross the void, to become more than observers, to become explorers. So, we built a ship, Starseeker, crafted to carry our hopes across the cosmic ocean. It is the most ambitious vessel ever constructed, a testament to our ingenuity and determination. Our mission: travel to Proxima Centauri b, the closest known exoplanet, 4.2 light-years away. This journey marks the first time humans will leave the comfort of our solar system. Even with advanced propulsion, the journey will take decades. Generations will be born, live, and grow old between the stars. We are the first generation to live our entire adult lives between the stars. Our home is no longer a single planet, but the vastness of space itself. Pioneers, explorers, scientists, united as ambassadors of Earth. Each of us carries the dreams and hopes of billions. The Starseeker mission is a symbol of global unity, supported by every nation. Never before has the world come together for a single purpose on such a scale. Our crew is a tapestry of humanity, woven from many cultures and backgrounds. We celebrate our differences, knowing they make us stronger. We seek answers. Can Proxima b support life? What secrets does this distant world hold for us? Is there water, an atmosphere, a future home? Could this be the place where humanity plants its next roots? These questions drive us through the silent, star-dusted darkness. Every day, we push further into the unknown, guided by curiosity and hope. On Earth, peace and cooperation made this mission possible. Our unity is our greatest strength, and our shared vision propels us forward. We are not just traveling to another star system, but to the future of our species. This is the next chapter in the human story. The cosmos beckons, and we have answered. Our journey is a promise to all who come after us. This is our new beginning, a dawn not just for a few, but for all of humanity. We are on our way, forging a path to the stars, and to the future that awaits us. The Starseeker is more than a machine. It is our world, a vessel carrying the hopes and ambitions of generations. It is a living testament to our determination to reach beyond the boundaries of our home planet. Nearly 2 kilometers long, it's a city in miniature. A self-contained biosphere where every system is carefully balanced. Within its walls, thousands of people coexist, each playing a vital role in the survival of our community. Its shimmering alloy hull shields us from micrometeoroids and radiation, forming an unyielding barrier between us and the void. The hull is a marvel of engineering, layered and reinforced to withstand the harshest conditions of interstellar travel. At the rear, antimatter drives propel us forward, a man-made star guiding us through the darkness. These engines burn with the brilliance of our ingenuity, pushing us ever closer to new worlds. The central rotating cylinder, the habitation ring, creates artificial gravity, allowing us to walk, run, and live as we did on Earth. This innovation preserves our health and sense of normalcy on our long journey. Here, we live, eat, sleep, and find a slice of Earth among the stars. Families gather, friendships form, and life continues, even as we travel light years from home. Parks and recreation areas offer comfort and familiarity, with green spaces and fresh air recycled through living plants. These places remind us of the world we left behind and inspire hope for the one we seek. The front houses the command and science section, with a panoramic bridge and advanced labs. From here, we chart our course and study the mysteries of the cosmos. Scientists analyze cosmic data, searching for clues about our destination and unraveling the secrets of the universe. Their discoveries shape our journey and our future. The Starseeker is a testament to human ingenuity, a cathedral of science sailing the stars, built on centuries of dreams and relentless pursuit of knowledge. Every module, every system is designed for survival and discovery, from life support to navigation, all working in harmony to keep us safe. The ship's design reflects our adaptability and ambition, its sleek lines and resilient structure a symbol of our will to endure. It is both sanctuary and laboratory, a place where we nurture our humanity and expand our understanding of the universe. Our journey is possible because of this marvel of engineering, the result of countless minds working together across generations. The Starseeker is our home, our hope, and our future. A beacon shining in the darkness, carrying us toward the unknown. We trust it with our lives, knowing that every journey, every challenge, is met with resilience and unity. It carries not just people, but the dreams of an entire planet, the legacy of those who dared to imagine a future among the stars. This is humanity's greatest voyage, a journey of hope, courage, and discovery as we sail ever onward into the cosmic unknown. Life aboard the Starseeker follows a steady rhythm. Our ship's clock mimics Earth's 24-hour cycle, with simulated sunrises and sunsets. Morning meals in the communal hall bring us together before our duties begin. Structured days, work, meals, exercise, recreation give us stability and purpose. Each crew member has a vital role, creating a strong sense of shared duty. We are a family relying on each other for survival and sanity. Hydroponic and aeroponic farms provide fresh food and a touch of green. The sight of living plants soothes us, reminding us of Earth. Nutritionists plan our diets for health and well-being. Simple pleasures, a fresh tomato, a crisp apple, mean everything out here. Evenings bring simulated sunsets and brilliant stars outside our windows. We gather in the observatory, watching the cosmos drift by. Our daily life is a blend of routine and wonder, set against a cosmic backdrop. This is how we endure and thrive between the stars. Every crew member is a specialist, each role vital to our mission. As an astrobiologist, I analyze data from our sensors, searching for signs of life. Engineers keep the ship running, maintaining the antimatter drive and life support. Their vigilance ensures our survival. Medical and psychological teams care for our bodies and minds, monitoring health and morale. Botanists manage our farms, while communications officers maintain our link to Earth. Pilots and navigators chart our course through the cosmos. Each role is a thread in the fabric of our mission. We are a microcosm of human society, working together toward a common goal. Among the stars, teamwork is our greatest strength. Technology is the invisible architecture of our lives on Starseeker. Every moment, it quietly supports us, weaving together the systems that keep us alive and thriving as we journey through the cosmos. Biosensors monitor our health, alerting doctors to any issues before they become serious. These sensors track everything from heart rate to hydration, ensuring that even the smallest changes are noticed and addressed. Hydroponic and aeroponic bays, managed by AI, provide abundant, healthy food. Fresh greens, fruits, and vegetables grow year-round, their roots suspended in nutrient-rich mist or water, untouched by soil. 3D food printers create a variety of meals, offering comfort and variety. With every meal, we taste a reminder of Earth, and the technology allows us to experiment with new recipes, keeping our spirits high. Communication with Earth uses quantum entanglement for urgent messages, and laser beams for everything else, delayed by years as we travel farther. Staying connected, even across the void, is vital for our morale and mission. Recycling is essential, water is purified and reused, air is scrubbed and refreshed by our plants. Every drop and every breath is precious, and nothing is taken for granted in our closed environment. Nothing is wasted, every resource is part of a closed-loop system. Waste becomes fuel, nutrients, or raw material, feeding back into the cycle that sustains us. We are a self-sufficient island of life in the vastness of space. Surrounded by endless darkness, our ship glows with the energy of human ingenuity and hope. Our ecosystem is delicate, but resilient. Each plant, each microbe, plays a role in maintaining the balance that keeps us alive. Technology sustains us, but it is our discipline that keeps us alive. Daily routines, constant vigilance, and teamwork are as vital as any machine. Every system is monitored, every process optimized. We analyze data, anticipate problems, and act before small issues become threats. We adapt, innovate, and endure. When challenges arise, we meet them with creativity and resolve, always learning and improving. The Starseeker is a marvel of sustainability. Every system, every process is designed for the long journey ahead. Our survival depends on balance between technology, nature, and ourselves. We are caretakers of this fragile world we carry with us. This is how we persist, light years from home, sustained by innovation, discipline, and the unbreakable will to endure. Even in deep space, we remain human. We need play, creativity, and connection. The habitation ring offers a gym, swimming pool, and digital library. Holographic simulation rooms let us walk on Earth's beaches or climb Everest. These escapes are vital for our well-being. We celebrate birthdays and holidays, share movie nights and organize sports tournaments. Art classes, book clubs, and music fill our free time. These activities build friendships and a sense of belonging. Isolation is real, but we face it together. We talk, share our hopes and fears, and find comfort in community. Looking out at the stars, we feel purpose, not loneliness. We are a beacon of human consciousness, traveling through the darkness. Our bonds keep us strong. Together we are more than the sum of our parts. Our journey is as much inward as outward. Excitement fills the ship. We are living the dream of generations. Each day brings us closer to a new world, fueling our work and resolve. But fear is ever present. The thin hull, the unknown at Proxima b, the risks of space. We acknowledge our fears, but hope guides us. We hope to find a habitable world, to discover life, to inspire future generations. These emotions, excitement, fear, hope, shape our days. Loneliness can be heavy, but images of Earth remind us what we fight for. We are emissaries for billions left behind. Our connection to home gives us strength. We navigate our inner cosmos as we cross the stars. This emotional journey is as profound as the physical one. It is what makes us human, even in the void. Years pass, and Proxima Centauri grows from a point of light to a disk. Our destination, Proxima b, orbits a dim red dwarf star. Long-range telescopes begin analyzing its atmosphere. The ship buzzes with anticipation. This is the moment we've traveled for. We detect water vapor, essential for life. Elation sweeps the crew. Oxygen and methane appear in the data, a possible sign of biological activity. It's not proof, but it's a powerful clue. We map continents, oceans, clouds, and polar ice caps. The planet looks familiar, full of potential. We are still years from orbit, but we have already made history. The hope for discovery defines us. We are explorers by nature, driven to see what lies beyond. The Starseeker mission is a testament to that spirit. We search for new worlds, and for a deeper understanding of ourselves. The universe is the ultimate wilderness. We are ready to explore it. Our journey is far from over, but we have already changed. We are a new kind of human, living between the stars. Children born here will know only the ship and the cosmos. For them, Earth is a legend, a story of origins. Exploration drives progress, innovation, and unity. Lessons from Starseeker will help Earth become more sustainable. Space exploration is an investment in our future. We dream of colonies on distant worlds, of a galactic network of knowledge. The Starseeker is just the beginning, a first step into the cosmos. Every star is a potential sun, every point of light a possible home. Our destiny is to journey outward, to find our place among the stars. The future is waiting for us. Beyond Neptune lies the Kuiper Belt, a vast, icy frontier filled with ancient leftovers from the birth of our solar system. It's a cosmic attic preserving the original ingredients that built the planets, including Earth. These icy objects are pristine relics, holding secrets from billions of years ago. By exploring the Kuiper Belt, we uncover the story of our cosmic origins. Ready to explore? Let's dive in. To find the Kuiper Belt, picture the solar system's layout. Earth orbits the Sun at 1 astronomical unit, or AU, about 93 million miles. Jupiter is 5 AU out, Neptune at 30 AU. The Kuiper Belt begins just beyond Neptune, stretching from about 30 to 50 AU. That's a colossal ring, 20 times the distance from the Sun to Earth. Sunlight takes over 4 hours to reach its inner edge, and more than 7 hours to reach the outer edge. The Kuiper Belt isn't a flat disk. It's a puffy, swollen donut, with objects orbiting at all sorts of angles. Neptune's gravity has shaped this region, flinging objects into tilted orbits and sculpting its structure. When you look up at the night sky, imagine flying past the planets. Beyond Neptune, into the cold and dark, where the Kuiper Belt begins. This hidden territory is hundreds of times larger and thousands of times more massive than the asteroid belt. It's the true frontier of our solar system, a vast wilderness we're only beginning to explore. The Kuiper Belt is our cosmic backyard, and it's huge. Its scale and mystery make it one of the most intriguing regions in astronomy. Let's see what lies out there. The Kuiper Belt is teeming with icy bodies, hundreds of thousands larger than 60 miles across, and trillions of smaller ones. These Kuiper Belt objects, or KBOs, are the ancient building blocks of the outer solar system. Unlike rocky asteroids, KBOs are dirty snowballs, made of rock and frozen substances. Water, methane, ammonia, and nitrogen. They're the raw ingredients that could have formed giant planets like Jupiter and Saturn. Most KBOs are small and irregular, but some are large enough to be round. These are dwarf planets. Pluto is the most famous, but others like Eris, Makemake, and Haumea are out there too, each with unique features. Haumea spins so fast it's shaped like a squashed egg. Makemake's surface is reddish from complex organics. KBOs orbit the Sun, some on stable paths, others on wild, elongated journeys. Occasionally, Neptune's gravity nudges a KBO toward the inner solar system. As these icy bodies approach the Sun, their ices vaporize, forming glowing comas and tails. We see them as comets. Many comets that light up our skies began their journey in the Kuiper Belt. Each KBO is a frozen time capsule, holding clues to the solar system's formation. Studying them helps us understand how planets and comets are born. The Kuiper Belt is a living museum of our solar system's past. Let's meet its most famous residents. The Kuiper Belt's discovery was a slow-burning mystery. In the 1940s and 50s, astronomers like Edgeworth and Kuiper predicted a belt of icy debris beyond Neptune. For decades, it was just a theory. These objects were too faint and distant to detect. Pluto, discovered in 1930, was thought to be a lone oddball. That changed in 1992, when astronomers David Jewett and Jane Liu found a faint, slow-moving object, 1992 QB1. This was the first confirmed Kuiper Belt object since Pluto, proof the hidden realm was real. Suddenly the solar system was bigger and more crowded than we'd imagined. With better telescopes, astronomers found dozens, then hundreds, then thousands of KBOs. The Kuiper Belt went from theory to reality, revealing a bustling region at the edge of our solar system. Pluto was no longer alone. It was part of a vast family of icy worlds. The discovery transformed our understanding of the solar system's structure. The Kuiper Belt became a new frontier for exploration and discovery. Each new object found added to the story of our origins. The hidden realm was finally revealed, and the search continues. For decades, Pluto was the ninth planet, a distant, mysterious world. But as we discovered more Kuiper Belt objects, Pluto's status changed. In 2005, astronomers found Eris, a KBO even more massive than Pluto. This sparked a debate. If Pluto was a planet, what about Eris and the others? In 2006, the International Astronomical Union redefined what makes a planet. Pluto met two criteria. It orbits the Sun and is round, but it hasn't cleared its neighborhood of other objects. Pluto was reclassified as a dwarf planet, the prototype of a new category. Far from a demotion, this made Pluto the king of the Kuiper Belt, the largest and most famous member of a vast icy kingdom. Understanding Pluto as a KBO is more exciting than seeing it as a misfit planet. Pluto is a dynamic world. It has a thin nitrogen atmosphere, vast plains of frozen nitrogen, towering water ice mountains, and possible cryovolcanoes. It's the ruler of a complex, active realm at the solar system's edge. Pluto's story highlights the richness of the Kuiper Belt. It's a kingdom of worlds, each with its own secrets. For years, the Kuiper Belt was just a collection of faint dots, until NASA's New Horizons mission. Launched in 2006, New Horizons traveled nearly 3 billion miles to give us our first close-up look at Pluto. In July 2015, it flew past Pluto, revealing a world more complex and active than anyone expected. We saw its heart-shaped plains, icy mountains, and dynamic atmosphere, but New Horizons didn't stop there. Using the Hubble Space Telescope, the team found another target, Arrokoth, a small KBO deep in the belt. On New Year's Day 2019, New Horizons flew past Arrokoth, a contact binary shaped like two pancakes stuck together. Arrokoth is a pristine relic from the dawn of the solar system, showing how planetesimals form through gentle accumulation. These flybys gave us a direct look at our origins, a snapshot of planet building frozen in time. New Horizons transformed the Kuiper Belt from a distant mystery into a place we can study up close. Each encounter reveals more about how our solar system came to be. The journey to the Kuiper Belt is a journey to our own beginnings, and there's still so much more to discover. The Kuiper Belt holds a tantalizing mystery, a possible ghost planet. Some distant KBOs have orbits that are strangely aligned, hinting at the gravitational pull of something big. This led to the Planet 9 hypothesis, a giant unseen world, 5 to 10 times Earth's mass, lurking far beyond Neptune. If real, Planet 9 would take thousands of years to orbit the Sun. Finding it is a huge challenge. It would be incredibly faint and slow-moving, almost indistinguishable from distant stars. Astronomers are scanning the skies with powerful telescopes, searching for this cosmic phantom. Whether Planet 9 exists or not, the search reveals the Kuiper Belt's dynamic nature. The strange orbits of distant KBOs are clues to the solar system's hidden architecture. The hunt for Planet 9 is a cosmic detective story, pushing the boundaries of our knowledge. If discovered, it would reshape our understanding of the solar system. The Kuiper Belt is not a static place. It's alive, with mysteries waiting to be solved. Each clue brings us closer to uncovering the secrets of our cosmic neighborhood. The search continues, and the next great discovery could be just around the corner. Why study the Kuiper Belt? Because it's a scientific time capsule. These icy bodies preserve the original chemistry of the early solar system. Far from the sun, they've remained frozen and unchanged for billions of years. Unlike inner solar system objects, KBOs haven't been melted, baked, or shattered. They're pristine. Studying them is like finding a perfectly preserved ancient artifact. The discovery of Arrokoth confirmed theories about gentle planet formation, planetesimals sticking together over millions of years. Arrokoth is a fossil of planet formation itself, letting us test our models of how worlds are built. The Kuiper Belt also helps explain the late heavy bombardment, a period when comets and asteroids bombarded the inner planets. Many scientists think giant planet migrations disrupted the Kuiper Belt, sending icy bodies inward. Some of Earth's water may have come from Kuiper Belt comets. Our origins are tied to this distant icy realm. The Kuiper Belt is a window into the solar system's past. By studying it, we learn how our world and life became possible. We've journeyed to the edge of our solar system and discovered a vast dynamic kingdom, the Kuiper Belt. It's not just empty space, but a realm ruled by dwarf planets, birthplace of comets, and maybe home to a hidden giant planet. The Kuiper Belt has expanded our vision of the solar system, revealing a complex, layered history. It's the solar system's attic, preserving the original building blocks for over 4 billion years. By studying these icy relics, we uncover the story of our own origins. The New Horizons mission gave us a glimpse of this frozen frontier, but the exploration is just beginning. Future missions and powerful telescopes will map the belt in detail, discover new worlds, and continue the hunt for Planet 9. Each discovery adds a piece to the puzzle of how our solar system formed. The Kuiper Belt reminds us there are always new frontiers to explore and mysteries to solve. The dark expanse beyond Neptune isn't an ending. It's the beginning of our solar system's story. It's a story frozen in time, waiting for us to read. The Kuiper Belt is one of the most important places in the universe for understanding our place in it. Our journey to the edge is just the start. The adventure continues. We are an exploring species. From the moment we first looked up, the vastness above has called to us, igniting a spark of wonder that has never faded. Curiosity is in our DNA, driving us to look up at the night sky and wonder what lies beyond. It's a force that shapes our dreams and fuels our imagination, compelling us to seek answers to questions we can barely articulate. For millennia, our ancestors gazed at the stars, inventing myths to explain the mysterious lights above, and, eventually, developing science to unravel their secrets. Each generation built upon the last, turning curiosity into knowledge. This relentless desire to know what lies beyond is our greatest inheritance. It's a legacy passed down through stories, discoveries, and the urge to reach further than before. It's the force that took us from caves to the moon, from stone tools to spacecraft. Our achievements are monuments to this drive, each one a testament to our refusal to accept the limits of the known. Today, our cosmic wanderlust is stronger than ever. With powerful telescopes and robotic explorers, we peer deeper into the universe, searching for new worlds and new possibilities. We've mapped our world, sailed every sea, and now we turn our gaze outward, ready to cross new frontiers. The universe is vast, and our journey has only just begun. The outer solar system, home to giant worlds and profound secrets, beckons us with mysteries waiting to be solved and landscapes no human has ever seen. Beyond the asteroid belt, immense planets and their moons hold clues to our origins, and perhaps even to life itself. Each discovery brings us closer to understanding our place in the cosmos. The journey will be long, filled with challenges and unknowns, but the human spirit thrives on challenge. We are at our best when we push boundaries and venture into the unexplored. This next chapter isn't just about travel, it's about expanding what we call home. It's about redefining our sense of belonging and embracing the universe as part of our story. The outer solar system is not just a destination, it's our destiny. It represents the next step in our journey, a place where new adventures and discoveries await. Our story continues, driven by our unquenchable thirst for the unknown. As long as there are mysteries to solve and horizons to chase, humanity will keep reaching for the stars. Imagine a realm where planets dwarf Earth, colossal gas and ice giants swirling in the cold, distant reaches of our solar system. These worlds are so massive that Earth would seem like a tiny marble beside them, lost in their immense shadows. Jupiter, the king, is a swirling masterpiece of storms, its great red spot larger than Earth. This giant is a world of endless motion, with clouds racing around its equator and lightning storms that could swallow continents whole. Its gravity shields us from cosmic threats, a silent guardian, deflecting comets and asteroids that might otherwise threaten our fragile world. Without Jupiter, Earth's history could have been far more violent. Saturn, with its ethereal rings, is a poet's planet, its beauty unmatched. The rings, made of countless icy fragments, stretch for hundreds of thousands of kilometers, casting delicate shadows that dance across the planet's golden clouds. Beyond, Uranus rolls on its side, a blue-green enigma spinning in a way no other planet does. Neptune, a vibrant azure, whips with supersonic winds, its storms swirling faster than the speed of sound. These ice giants are mysterious, their atmospheres hiding secrets we are only beginning to uncover. But the true wonders orbit these giants, over 200 moons, each a world of its own, with landscapes and mysteries as diverse as the planets they circle. Some are icy, some volcanic, and some may even harbor the ingredients for life. Io is a volcanic inferno. Its surface is constantly reshaped by eruptions more powerful than any on Earth, painting the moon in brilliant yellows and reds. Europa, a smooth ice ball, may hide a vast ocean beneath its frozen crust. Scientists believe this hidden sea could be one of the best places to search for life beyond our planet. Titan, Saturn's largest, has lakes of methane and a thick atmosphere. Its orange haze hides a landscape eerily reminiscent of Earth, with rivers, lakes, and even rain, though made of liquid methane instead of water. Triton, Neptune's moon, orbits backward and erupts nitrogen ice from its frozen surface, creating geysers that reach kilometers into space. Its retrograde orbit hints at a dramatic past, perhaps once a wandering object captured by Neptune's gravity. These moons are dynamic, complex, and perhaps the best places to search for life beyond Earth. Each one is a laboratory of extremes, offering clues to the origins of our solar system and the potential for life elsewhere. The outer solar system is a collection of worlds, each with mysteries waiting to be explored. From swirling storms to hidden oceans, these distant realms challenge our understanding and ignite our curiosity. Our journey is not just to planets, but to the jewels that orbit them, moons that may one day reveal the secrets of life, chemistry, and the universe itself. Here, the story of life and the cosmos may be written in icy crusts, volcanic plains, and alien atmospheres. The adventure is just beginning, and the next great discoveries await those bold enough to seek them among the giants and their dazzling jewels. To reach these distant worlds, we need new ways to travel. Chemical rockets are relics, the future belongs to starships powered by light and fusion. Solar sails, vast, ultra-thin sheets, catch the gentle push of sunlight, accelerating steadily across the void. For heavier missions, fusion rockets, miniature suns, promise immense power and speed. Fusion could shrink journeys to Jupiter from years to months, These technologies break the limits of traditional rockets, letting us harness cosmic energy. Light sails and fusion drives are no longer science fiction, they're being built today. They will be the engines that carry us to the moons of Saturn and beyond. The age of true interplanetary travel is dawning. Our reach is limited only by our imagination and ingenuity. Our first outposts in the outer solar system will be on Jupiter's moons. We won't land on Jupiter itself, but on its Galilean moons, Io, Europa, Ganymede, and Callisto. Callisto, outside Jupiter's harshest radiation, is the logical first base, rich in ice and rock for water, oxygen and fuel. Habitats will be carved beneath the surface, shielded from radiation. From Callisto, we'll explore Ganymede, the largest moon, with its own magnetic field and vast icy plains. Ganymede could become a hub for science and industry. Europa, with its subsurface ocean, is the ultimate prize, a place where life may exist. Our mission, drill through Europa's ice and search for life in its alien sea. These moons are stepping stones, each a new home and a new mystery. The quest for life and knowledge begins here. Picture waking up on Europa, deep beneath the ice, shielded from deadly radiation. Your home is a network of tunnels and domes, glowing with artificial light. Life here is about survival and discovery, operating robots, analyzing ice, maintaining reactors, and growing food. Every role is vital. Teamwork is survival. Surface journeys are slow, deliberate, and breathtaking. Jupiter looms above, the ice below is alien and beautiful. Despite the isolation, a unique culture will flourish: art, music, and community, shaped by this frontier. Children born here will know Jupiter as their sky, Earth as a distant star. They'll be the first generation of true outer solar system pioneers. Life on Europa is a new chapter for humanity. After Jupiter, Saturn's realm awaits, especially its largest moon, Titan. Titan is unique, a thick, nitrogen-rich atmosphere, methane lakes, and icy mountains. Landing here means descending through orange clouds to a world both familiar and alien. Habitats must withstand deep cold, powered by advanced reactors. Titan's atmosphere shields settlers from radiation, allowing surface bases with windows to the surreal landscape. Scientists will explore methane seas and search for exotic life. Enceladus, another Saturnian moon, shoots water plumes, another target in the search for life. The Saturn system is a kingdom of wonders. Icy moons, mysterious rings, and endless scientific puzzles. Each world offers new resources and new questions. Saturn's moons are not just destinations, they're gateways to the next phase of exploration. The adventure deepens with every step outward. The final leg takes us to Uranus and Neptune, true deep space. These ice giants are shrouded in mystery, their faint sunlight and extreme cold a challenge for explorers. Robotic outposts will study Uranus's bizarre moons, Miranda's shattered surface, Ariel's ancient scars. Power will come from fusion reactors. Humans may oversee from afar, telecommuting across the void. Neptune's moon, Triton, with its backward orbit and icy geysers, is a gateway to the Kuiper Belt. These worlds are laboratories for understanding planetary formation and the diversity of planets in our galaxy. Studying their atmospheres and interiors will reveal how solar systems evolve. The ice giants may be common across the cosmos. Unlocking their secrets is key to understanding our place in the universe. Each discovery here echoes back to our own origins, the deep, dark whispers with the promise of knowledge. Our journey is far from over. Every age of exploration transforms us. The Apollo missions gave us the overview effect, a new sense of unity and fragility. Living on distant moons will change our perspective even more. Old divisions will fade. We'll become citizens of the solar system. Discovering life elsewhere would reshape our science, philosophy, and sense of self. We'll see ourselves as one branch on a universal tree of life. By expanding outward, we'll expand inward, growing new cultures, art, and ways of thinking. The cosmos will reflect not just what we are, but what we can become. We stand at the edge of an ocean of stars, our history behind us, our future ahead. The universe stretches out before us, vast and mysterious, inviting us to dream bigger than ever before. Each star is a beacon, a reminder of how far we've come and how much further we can go. The path forward will be hard, demanding courage, resilience, and a willingness to face the unknown. Every step into the cosmos tests our resolve and our imagination. Intelligence and unity will be our greatest tools. Only together, combining our strengths and knowledge, can we overcome the challenges of space. Exploring the outer solar system isn't an escape, it's a solution, teaching us sustainability and unity. As we build new worlds, we learn to care for our own, and for each other, in ways we never imagined. The technologies and lessons we gain will benefit Earth and beyond. Children born on Ganymede or Titan will inherit a legacy of exploration, innovation, and hope. For them, Earth will be a legend, a blue cradle in the stories of their ancestors, while space becomes their home. They'll be pioneers, dreamers, and builders of new civilizations. They will build ships for interstellar journeys, forging paths to distant stars, carrying humanity's spirit farther than ever before. We are laying the foundation for their future, taking the first steps so they can run. Our actions today will echo through generations, shaping destinies we can only imagine. The cosmos is a story of change, of endless transformation and possibility. And now, we write a new chapter. For the first time, a species reaches out, not just to visit, but to belong, to make the solar system its home. We are stardust, awakened, writing our destiny among the stars. Our journey is just beginning, and the universe awaits our story. The future is not given, it is created. Every choice, every leap forward shapes what comes next, and we will create it, together, as one people, united by hope and curiosity, in the grand, silent darkness. Our future is written in the stars, and it begins now.